Okay, so I wanted to model some thinking behind a question in the textbook. So I just chose this one randomly from the chapter on isomorphisms. And it asks about the group of matrices that has entries 1A0, 1, where A is an integer. And since A is an integer, at first we might think that this set of matrices has the operation of addition. But when we think about adding matrices of this form, so maybe I'll make this B, we can see right away that we're going to get 2's on the diagonal. And that's not an entry in our group. Actually, we don't have a name for it yet, so let's just call it G. That's not an element of G. So the addition operation is not going to work here. So let's come up with a different possibility. So I guess the other operation that we have on matrices is multiplication, or that's the other one that we think of. And we know that since these matrices have a diagonal of 1s, that's going to be preserved when we multiply them. Okay, and again, I should make this a B or something like that. And also integer entries are going to be preserved. So this will definitely, actually I don't even need to compute it right now. This will definitely be an element of G. Okay, so what have I done so far? Well, I've just been getting to know the problem. Get to know the context. Okay. And so first of all, I'm just trying to understand my group. So G is a group under multiplication. So G has the operation of multiplication. So I usually start any problem by writing out what I know and what I want to find. Okay, so what I know is basically exactly this. I know about G. I know what its members look like, and I know that I have multiplication. I also know that A is an integer. Okay, and so let's be clear on what we want to find. Okay, I want to find some other group that is isomorphic. To G. Okay, so how can I get there? So I need to build a bridge here. This is a bridge. And the way that I usually do this is by thinking about what I know in as many different ways as possible. So let's rewrite what I know in as many ways as it takes. Okay. So what really matters here is just this entry. Only thing that matters. So I'm going to have an infinite number of things in here. So I guess I can start to write out elements of G. So G is equal to things like 1, 0, negative 2, 1. It's equal to 1, 0, negative 1, 1. 1, 0, 0, 1. 1, 0, 1, 1. 1, 0, 2, 1. 1, 0, 3, 1. And I can keep going in the positive direction. And I could also keep going in that negative direction. Okay, so those are some elements. And so I can see that, like, the elements are a countable infinite set. So this is a countable infinite set. So it needs to be isomorphic to some other countable infinite set. And how many countable infinite groups do we know? We don't know very many, right? We kind of know Z as the first one. And I guess things built from Z. It's the only thing that I know. Okay, so let's see. Could G be isomorphic to Z? The integers. Let's see. I need a little bit more room, so I'm just going to minimize this part. Okay. Could G be isomorphic to Z? But remember that Z carries with it the operation of addition. I guess another countable infinite thing that actually has multiplication is Z minus 0 times multiplication, but then that doesn't quite work because I don't get inverses. Okay, so that's not a group. Shouldn't think about that. But I do have Q. Q is a countable infinite set. Q is a countably infinite set. Under multiplication when I remove 0. Yes, I have to remove 0 from Q and under multiplication. So which one is going to work here? So I guess it's going to be easiest to have a map to Z. So let's try that one first. Okay, so if I have a map from G to Z, it would take the matrix 1, 0, A1 to A. Okay, and so to be an isomorphism, it has to respect the operation. It has to be 1 to 1 and onto. So 1 to 1 and onto should be pretty clear. But for it to respect the operation is maybe a little bit more questionable. So let's see. So I have to show that if I have phi of a matrix, so let's see, let's call them alpha times beta, that's going to equal phi of alpha plus phi of beta. And notice I'm using plus because over in Z, the operation is plus. Okay, so let's write that out. So I'm going to be multiplying matrices 1, 0, A1 times 1, 0, B1. And that should equal just A plus B. Oh, and I forgot my phi. Phi of that. Okay, so let's see. So phi of, and then I have to do some matrix multiplication. So I have 1 times 1 times 0. So I get the 1 that we were expecting in the top. And then in the top right entry, I have 1 times B plus 1 times A plus B. And then in the bottom left, I have 0 again. So 0 times 1 plus 0 times 1. And in the bottom right, I get 0 times b plus 1. Okay. And then that should equal a plus b. And I realize that I just have, this should be a question mark. Make that really clear that this is a question still. And then indeed, under my map, this gets sent to the top entry. So we get a plus b is equal to a plus b. Okay. So indeed, that's correct. So this map is operation preserving. So phi is operation preserving. Okay, and thus G is isomorphic to Z. Okay, so notice here that I have ultimately gotten maybe the conclusion that you were expecting in the very first place, but I had to go through a little bit of work. I had to get to know the context, then write down what I knew and what I wanted to find, and then I needed to write down what I knew in a couple different ways to make it, my guess, really clear. And I wanted to write down also my guesses, what I wanted to find in a couple of different ways. And then establishing this bridge, I think, is the key to solving any problem of this level or proving anything like this.